Question number second, part number first, exercise number 2.1. The question is, if possible, find the matrix A. The matrix A is a matrix. Multiply this matrix with the matrix having element in the first row are 2, minus 3, and the elements in the second row are 0, 1, and the resultant matrix, the elements in the first row in the resultant matrix is equal to minus 2, 5, and in the second row the elements are 8 and minus 7. Suppose this matrix is denoted by B and this matrix is denoted by C. The solution of the matrix A is possible only when the inverse of the matrix B is possible. For the inverse of the matrix B, first we have to check the condition. The first condition is when the matrix A is a square matrix, when the matrix B is a square matrix. So the order of the matrix B is 2 cross 2. So the order of the matrix B is 2 cross 2, and the matrix B is a square matrix. And the second condition, we have to check the second condition. The second condition is when the matrix B is non-singular. For that, we calculate the determinant of the matrix B. The determinant of the matrix B is equal to 2 minus 0, which is equal to 2. So the matrix B is non-singular matrix. The matrix B is non-singular matrix. Therefore, the inverse of the matrix B is exist. In this case, for the calculation of the inverse of the matrix B, we have to calculate the cofactor of each element of the matrix B. Calculate the cofactor of the first row, the element of the first row and first column of the matrix B. We have minus 1 raised to power 1 plus 1 multiply by, delete the first row and first column. After the simplification we get 1. After this simplification we get 1. 1 multiplied by 1 is equal to 1. The cofactor of the first row and second column, this element is minus 1 raised to power 1 plus 2. Delete the first row and second column. After the resultant quantity is equal to 0. This quantity is equal to 0. The cofactor of the element of the second row and first column is minus 1 raised to power 2 plus 1 multiply by, delete the second row and first column. After we get minus 3, which is equal to minus 1 multiplied by minus 3 is equal to 3. Second row and second column, minus 1 raised to power 2 plus 2. Delete the second row and second column. After the simplification we get 2. Minus 1 raised to power 4 is equal to plus 1 multiplied by 2 is equal to 2. Replace each element by its cofactor. Replace 2 by minus 1, 3 by 0, 0 by 3, and 1 by 2. We get another matrix. Let us denote that matrix by D. The transpose of D, taking the transpose of D, first row in first column, second row in second column, that resultant matrix is equal to adjoint of the matrix B. Now to calculate the inverse of a matrix, we apply the formula, which is B inverse is equal to 1 divided by determinant of B multiplied by adjoint of B. Substitute the value of the determinant of B and adjoint of B. Adjoint of B is a matrix. Substitute these values. We have B inverse is equal to 1 over 2, 1, 3, 0, and 2. And this is a scalar. This is a matrix and this is a scalar. And the scalar multiplication of a matrix is a matrix. When we multiply a matrix by a scalar, we multiply each element of the matrix by that scalar. 1 multiplied by 1 over 2 is equal to 1 over 2. 3 multiplied by 1 over 2 is equal to 3 divided by 2. 0 multiplied by 1 over 2 is equal to 0. 2 multiplied by 1 over 2 is equal to 1. This matrix is equal to the inverse of the matrix B. Substitute the value. Now equation first implies we have to rearrange the equation number first. equation first state is A multiplied by B is equal to C. Now rearrange this equation. Multiply this equation by B inverse. A multiplied by B inverse is equal to C multiplied by B inverse. When we multiply any matrix with the matrix on the right hand side, when we multiply this side by the left hand side by on the right hand side, so on the right hand side of the equation number first, we multiply C by the B inverse on the right side. So this is equal to A multiplied by B inverse is equal to identity matrix is equal to C B inverse. And this is the property of the identity matrix is when we multiply any matrix by the identity matrix, we get the matrix, that matrix. In this case, the matrix is A, we get A. The matrix C is equal to, the elements in the first row is -2, 5. In the second row, 8, -7. And B inverse is equal to 1 over 2, 3 divided by 2, 0 and 1. And now it is a simple multiplication process to calculate the matrix A. Multiply the first row with the first column, -2 multiplied by 1 over 2 plus 5 multiplied by 0. This resultant quantity is equal to -1 plus 0. The resultant quantity is equal to -1. Multiply the resultant quantity of the in the resultant matrix is substitute in the first row and first column. Multiply the first row with second column, -2 multiplied by 3 divided by 2 plus 5 multiplied by 0 plus 5 multiplied by 1. After the simplification, we get -3 plus 5. The resultant quantity is 2. This quantity is obtained when we multiply the first row with the second column. Substitute that quantity in the first row and second column. Similarly, multiply the second row with second row with the first column. Add multiply by 1 over 2 plus 7 multiplied by 0. This quantity is equal to 4 plus 0. The resultant quantity is equal to 4. This quantity is substitute when we multiply the first row, second row, first column, second row and first column. Multiply the second row with second column. Add multiply by 1 over 3, 3 divided by 2 plus -7 multiplied by 1. This quantity is equal to 12 minus 7. The resultant quantity is equal to 5. This quantity is substitute in the second row and second column, which is our required target.